The sky didn't change that night. No alarms, no flashes, no warning. Just the same dark canvas humans have stared at for thousands of years. And somewhere in that silence, something was moving, far beyond the orbit of Mars, drifting along the ecliptic. An object was making its way toward the sun. Slow, quiet, predictable. At least, that's what everyone thought. They called it 3I/Atlas, a name that sounded routine, almost boring. Another catalogue entry. Another cold visitor passing through. For months, astronomers tracked it the same way they track everything else. Screens glowing in dark rooms, coffee cups going cold, numbers scrolling by one after another. Distance, speed, angle, all normal, nothing dramatic, nothing emotional, just data. And yet, there was a strange feeling in the air. Not fear, not excitement, something subtler, like waiting for a sound that hasn't arrived yet. Because interstellar objects don't come often. They are older than planets, older than Earth. They don't belong to us. They were born around other stars, in other systems, under other suns. They are messengers from places we've never seen. Still, no one expected anything unusual. 3I/Atlas was supposed to behave like every other cold traveler before it, reflect sunlight, warm up slowly, follow the math, follow the rules. That's how space works. Until it doesn't. The first real data arrived quietly. A light curve, just a simple graph, brightness over time. A basic tool astronomers have trusted for decades. It tells you how an object spins, what shape it has, whether it's smooth or broken or tumbling through space. Most light curves are boring. Up, down, repeat. But this one stopped the room. The curve wasn't smooth. It didn't rise and fall gently like a rotating rock. It stepped. Sharp changes, clean edges, sudden drops, followed by steady holds. Then another jump. It looked less like a natural spin and more like a switch being flipped. At first, nobody panicked. They never do. Probably noise, someone said. Bad calibration. Instrument error. That's the comfort of science. There's always a safe explanation waiting nearby. Something small, something fixable. So they recalibrated. They checked the sensors. They ran the numbers again. Same result. The light curve didn't change. If anything, it became clearer. 3. I/Atlas wasn't just reflecting sunlight. It was doing something else. The object brightened, then dimmed, then held steady, then changed again. Not randomly, not smoothly, deliberately. Across different observatories, on different continents, the same pattern appeared. Telescopes that had never spoken to each other were seeing the same thing. That's when the room went quiet. Because when data repeats itself across the world, it stops being a mistake and starts becoming a question. What kind of object changes its reflectivity in steps? Not ice, not rock, not dust. Comets flare chaotically. Asteroids tumble unevenly. Natural objects are messy. They wobble. They crack. They misbehave. This didn't. This looked controlled. But no one said that out loud. Not yet. Instead, they did what scientists always do when something feels uncomfortable. They waited. Days passed, then weeks. 3I/Atlas continued its slow approach toward perihelion, toward the heat, toward the place where most fragile objects fall apart. And the waiting became heavier. Every new observation added a little more tension. The brightness didn't drift. It adjusted. The pattern didn't decay. It sharpened, almost like the object was settling in, as if it knew where it was going. Somewhere between midnight shifts and early morning handovers, a quiet thought began forming in more than one mind. This doesn't feel blind. No emails were sent with that sentence. No reports were written with those words. But the feeling lingered, because space is vast and empty and cruel. Nothing survives there by accident for long. The sky outside the observatory windows stayed the same, calm, unbothered, beautiful. But inside, perception had shifted. For the first time, 3I/Atlas didn't feel like just an object passing through. It felt like something entering, something that had already crossed unimaginable distances, without breaking, without changing, without losing itself. And now it was here, still silent, still distant, still refusing to behave. The light curve sat on screens like an unanswered message, not loud enough to be called a signal, not strange enough to be called impossible, but wrong in a way that stayed with you, the kind of wrong that doesn't go away when you turn off the lights. Somewhere between science and instinct, a line had been crossed, and no one knew it yet. But this was the moment everything began. Because once you notice the sky watching back, you can never unsee it. And the next dataset was already on its way. The confirmation didn't arrive with applause. There was no countdown, no cheering rooms, no headlines racing across screens, just a quiet update buried deep inside a technical report. 3I/Atlas was not from here. It wasn't born with our sun. It didn't form from the dust that made Earth. It didn't share our history. It came from somewhere else, older than our solar system, older than every planet we know, a traveler shaped by another star, or maybe many stars, long before Earth even existed. On paper, this should have been a moment of celebration, the kind of discovery scientists wait their whole lives for. An interstellar object is rare, almost mythical, proof that the universe is not closed, that things move between stars, that we are not isolated. But something was different this time. There were no press briefings, no bold announcements, no smiling experts explaining what this meant for humanity. Instead, there was silence. Behind closed doors, conversations slowed. Voices, emails became shorter. Access to certain data quietly changed. It felt less like a discovery and more like a complication. Because as soon as the object was confirmed as interstellar, the questions changed. Where most objects have origins we can trace, this one didn't. Its trajectory didn't point cleanly back to a nearby star. It didn't scream its birthplace. It was detached, as if its origin had been erased by time or intention. Then there was its motion. Space is chaotic. Gravity pulls. Dust nudges. Radiation pushes over long journeys. Objects wobble. They drift. They lose precision. 3I/Atlas didn't. Its path through the solar system was almost too smooth, too clean, like a blade sliding through water. No unnecessary spin, no chaotic tumble, no wild deviation, just quiet accuracy. as if it knew exactly where it was going. And that's when the celebration stopped making sense. Because randomness leaves fingerprints, and this object had none. The more they studied its velocity, the stranger it felt. It wasn't rushing. It wasn't slowing in panic. It adjusted, gently, almost politely, as it passed through gravitational fields, not fighting them, not surrendering to them, just navigating. There's a word scientists don't like to use casually: purpose. No one wrote it in the reports. No one said it out loud. But the absence of chaos made it hard to ignore. Natural objects don't travel like this for millions of years and arrive intact. They chip. They crack. They forget their shape. 3I/Atlas remembered itself, and the age estimates only deepened the discomfort. This thing had been drifting between stars longer than our sun has existed. Longer than life on Earth, longer than memory. It had crossed radiation storms, stellar shockwaves, cold that freezes atoms into stillness, and yet it arrived clean, not scarred, not broken, preserved. That alone should have sparked awe. Instead, it sparked restraint, because the moment you accept its age, you accept something else. This object didn't just survive the universe, it mastered it. Still, the official tone stayed calm, neutral, careful, an interstellar visitor, a rare opportunity. Further observation required. Safe words, but beneath them, attention grew. Why wasn't this being shared? Why wasn't the world told to look up? Why did this discovery feel like something to manage, not celebrate? In observatories, researchers began double-checking who was copied on emails. Meetings happened without recordings. Some datasets were labeled internal only, not classified, just quiet. The silence wasn't fear, it was caution. Because once the public hears Interstellar, the imagination runs faster than the facts. People ask questions science can't answer quickly. And right now, science didn't have answers. The light curve was still wrong. The motion was still too precise. The object was still silent. No outgassing, no debris trail, no natural mess. Just an old thing moving through our system, like it had done this before. And maybe that was the problem. Because if this was just another rock, celebration would be easy. But if it wasn't, then celebration would be reckless. Somewhere along the line, a quiet realization settled in. Discoveries don't scare people. Implications do. And the implication here was unsettlingly simple. Something ancient had passed through the space between stars and arrived unchanged, not screaming for attention, not announcing itself. Just passing through, observed, measured, noticed, like it didn't care who saw it, like being seen was expected. The sky outside remained calm. The public slept peacefully, unaware that something older than history was gliding past their home star. No celebration, no warning, just data and silence. And in that silence, one question echoed louder than any announcement ever could. Why does a discovery this rare feel like a problem? Because deep down, everyone watching knew the real story wasn't where 3I/Atlas came from. It was why it came through at all. And the next observations were about to make that question impossible to ignore. The first warning wasn't loud. It wasn't dramatic. It was quiet and easy to miss. A line on a screen. A curve that didn't curve. As 3I/Atlas continued its journey inward, astronomers did what they always do. They watched how light touched it, how sunlight reflected off its surface, how brightness rose and fell as it moved and turned. This is one of the oldest tools in astronomy. The light curve. Simple, trusted, reliable. Natural objects behave in familiar ways. As they rotate, one side catches more light, then less. Brightness increases, then fades. Slowly, smoothly. Like breathing, that's how it's supposed to look. But this one didn't breathe. It blinked. The brightness jumped, then stopped. Dropped, then held. Rose again. Sharply, cleanly, no smooth transition. No gradual change, just steps, like someone turning a dial instead of letting it spin. At first, no one said anything, because science teaches patience and humility. You don't jump to conclusions. You question yourself first. So they blamed the instruments. Maybe the sensor lagged. Maybe cosmic noise slipped in. Maybe software smoothed the data wrong. They ran it again. Same steps. They switched telescopes. Same pattern. They waited for a longer window. Still the same. The light curve wasn't broken. It was precise. Too precise. Natural surfaces don't change reflectivity instantly. Ice sublimates. Rock heats unevenly. Dust clouds scatter light softly. This didn't soften. It switched on, off, hold, like it was following instructions. That's when the discomfort settled in. Because reflectivity isn't random. It tells you about surface texture, shape, material, motion. And nothing about this made sense. The object wasn't tumbling wildly. It wasn't venting gas. It wasn't shedding debris, yet its brightness changed, as if it wanted to, as if it chose when to reflect light, and when not to. Across the globe, observatories saw the same thing. Different skies, different nights, same behavior. The steps lined up, not exactly like a heartbeat, but close enough to feel wrong. Pulse, pause, pulse, pause. Not fast, not slow, measured. Somewhere between curiosity and unease, a question formed that no one wanted to ask. Why would an object change how it reflects light, unless it knew the light was there, unless it knew it was being observed? That thought stayed unspoken. Instead, charts filled with annotations. Numbers replaced emotions. Everything stayed professional, but people lingered longer at their desks. They stared at the graphs after the data finished loading, because once you see a pattern that shouldn't exist, you can't unsee it. The brightness didn't correlate with distance alone. It didn't match rotation models. It didn't behave like ice, or metal, or stone. It behaved like a response. As 3I/Atlas moved closer to the sun, the pulses became clearer, not stronger, clearer, like noise fading away to reveal a signal underneath. Some wondered if sunlight itself was triggering something, heating a layer, activating a reaction. That would have been comforting. But the timing didn't match. The shifts came too cleanly, too evenly spaced. Not delayed, not chaotic, intentional. And intent is a dangerous idea in science, because intent implies agency, and agency implies choice. Late one night, an astronomer leaned back in their chair and whispered something they would never write in a paper. It's acting like it knows where the light is coming from. That sentence hung in the air. No one argued, because the data didn't argue either. The object didn't just reflect sunlight, it modulated it. Like a surface that could change itself, like a skin that could open, then close. The brightness wasn't random glare, it was controlled exposure, and control changes everything. If this was a rock, it was the strangest rock ever seen. If it was a comet, it was missing all the mess that defines comets. And if it was something else, then the light curve wasn't broken. It was speaking, not in words, not in sound, but in behavior. A quiet language made of reflection and shadow. Pulse, silence, pulse. As days passed, the question grew heavier. Not, what is it, but why is it doing this now? Because timing matters. This wasn't happening in deep space, far from attention. It was happening as it entered the inner solar system, as telescopes locked onto it, as eyes turned toward it, as if observation itself changed the object, as if being seen mattered. The idea was unsettling, but impossible to dismiss, because every time attention increased, the pattern sharpened. No message was hidden in the pulses, no numbers encoded, no obvious math to decode, just behavior. A response without explanation, a mirror that didn't act like a mirror. And that's when fear crept in. Not panic, not terror, but something colder. Recognition. Because humans recognize patterns for a reason. Our ancestors survived by noticing when the forest went quiet, when animals froze, when something unseen watched back. This felt like that. The sky wasn't empty anymore. It was interactive. 3I/Atlas didn't glow beautifully. It didn't flare dramatically. It did something far more disturbing. It adjusted, as if it was aware but uninterested, as if the flashing wasn't for us, but simply something it did when light touched it, or worse, something it did when watched. The light curve kept stepping, the pulses kept coming, and the silence around the data grew thicker. Because now the question was unavoidable. What kind of object flashes like it knows it's being watched? And if it does know, what else does it know? The next chapter wouldn't bring answers. It would bring heat. And heat has a way of revealing what surfaces try to hide. It started as a doubt. A small one. The kind you can ignore if you want to. Because when something strange shows up in data, the first rule is simple. Assume you're wrong. Maybe the telescope glitched. Maybe the atmosphere interfered. Maybe the software smoothed something it shouldn't have. So the obvious solution was distance. If this pulse was real, it shouldn't care where you are. That's when the second observatory checked. Different continent, different instruments, different team. Same object, same light curve, same pulse. At first, it didn't hit all at once. The data came in through routine channels, shared folders, quiet uploads, time-stamped files reviewed late at night. But when someone overlaid the graphs, the room changed. The brightness spikes lined up, not roughly, not approximately, exactly, down to the second. A pulse in Chile, a pulse in Hawaii, a pulse in Europe, all seeing the same flash, at the same moment, from the same object. Millions of kilometers away. That's when coincidence stopped feeling like coincidence, because noise doesn't synchronize itself. Random errors don't agree across oceans. Atmospheric distortion doesn't care about global timing, but this did. Pulse, pause, pulse. The rhythm wasn't fast enough to feel frantic, and not slow enough to feel natural. It sat in an uncomfortable middle ground, like a clock you didn't know was ticking, until you suddenly heard it. At first, teams worked independently. No one wanted to jump ahead of the facts. No one wanted to be the first to say something embarrassing. But science has a way of forcing conversations. Emails began crossing time zones. Are you seeing this too? Can you confirm your timestamps? Did you correct for delay? Corrections were made. Still aligned. They adjusted for light travel time. Still aligned. They accounted for Earth's rotation. Still aligned. The pulses didn't drift. They didn't smear. They didn't decay. They repeated. That's when the word pattern began appearing in internal notes. Carefully, quietly, because pattern implies structure, and structure implies intention. But no one wanted to say that yet. Instead, they tried to break it. They searched for reasons it shouldn't line up. Solar flares, cosmic rays, satellite interference. Nothing fit. The pulse was coming from one place. 3I/Atlas. And only from it. As more observatories joined in, the picture sharpened. Each new dataset didn't add confusion. It reduced it. The noise fell away. What remained was clean, almost elegant. The brightness increased, held steady, then dropped. Again and again. Not a message, not a language, just behavior. And behavior is harder to dismiss than sound, because sound can echo. Light can scatter, but timing is deliberate. One researcher compared it to a lighthouse, not because it guided ships, but because it didn't care who was watching. It simply pulsed, because that's what it did. Another compared it to a heartbeat, not because it felt alive, but because it was steady, unbothered, as if it had been pulsing long before anyone noticed and would continue long after. That thought settled uneasily, because it meant the pulse wasn't for us. We were just in range. The realization changed the tone of everything. Before, the strange light curve was an oddity. Now it was shared. Global. Verified. No single telescope could explain it away. And once that happened, a quiet shift occurred. People stopped asking, "Is this real?" They started asking, "What does it mean?" But meaning is dangerous territory, because meaning suggests purpose, and purpose suggests design. Late-night meetings stretched longer. Slides were reviewed twice. Language became careful. No one used the word signal, but no one said noise anymore either, because noise doesn't wait for the sun. And as 3I/Atlas drifted closer to perihelion, the pulses didn't weaken. They clarified, like fog lifting, like static fading. The object wasn't getting louder. It was getting easier to hear. That's when someone noticed something else. The pulses weren't random in spacing. They followed a simple rhythm, not mathematically complex, not encoded, just regular. As if complexity wasn't necessary. As if simplicity was the point. And simplicity is unsettling, because the universe is messy. Stars flare. Planets wobble. Space is violent and chaotic. Regularity stands out. Regularity feels artificial. The thought crept in slowly, like cold air under a door. What if this wasn't a signal being sent, but a system operating? A process running, a machine doing what machines do. No emotion, no curiosity, No awareness of observers, just function. The pulse wasn't saying, hello. It wasn't saying anything. It was just happening. And that might have been the most disturbing part. Because if it was intentional communication, at least there would be a sender and a receiver. But this felt different. Like watching an engine cycle. Like observing a heartbeat that doesn't need you to exist. For the first time, the idea of alien intelligence felt small. This wasn't intelligence reaching out. This was something passing through, uninterested, unaffected, operating on rules we didn't write. The global alignment forced a conclusion no one wanted to rush toward. This wasn't error. This wasn't coincidence. This was consistency. And consistency demands explanation. At what point does coincidence turn into signal? Maybe when the universe repeats itself and asks you to notice. Or maybe when silence becomes impossible to ignore. As the pulses continued, one truth became clear. Whatever 3I/Atlas was doing, it wasn't hiding. It wasn't announcing itself either. It was simply revealing that something was there, something structured, something old, something that behaved the same way, no matter who watched or where. And the closer it came to the sun, the more dangerous that realization became, because heat has a way of testing systems. And the next phase wouldn't be about light. It would be about whether this thing could survive stress, or whether stress was part of the design. And if it was, then the anomaly wasn't just pulsing, it was preparing. Heat changes everything. It reveals cracks. It exposes weakness. It forces the truth out of silent things. As 3I/Atlas moved closer to the sun, scientists expected the moment that always comes. The point where space stops being gentle and starts to test you. Perihelion is unforgiving. Ice boils away. Rock fractures. Dust explodes into glowing tails. That's the rule. Every object that comes this close pays a price. So when thermal instruments locked onto 3I/Atlas, the expectation was simple. Temperature would rise steadily, predictably. Sunlight in boat, heat up, end of story. But that's not what happened. The first readings made no sense. Instead of warming smoothly, the object cooled, not slowly, rapidly, as if heat was being pulled away. At first, they assumed a shadowing effect. Maybe the object was rotating in a way that hid its warmer side. Maybe a plume of gas was carrying heat off the surface. Reasonable explanations. Comforting ones. But the cooling was too fast, too uniform, too intentional. Then something stranger happened. The temperature rose again. Not as a spike, as a controlled climb. It didn't overshoot. It didn't flare. It didn't panic. It leveled out and held, like a system finding balance. Natural objects don't do that. Ice doesn't choose when to cool. Rock doesn't decide when to warm. Matter reacts. It doesn't regulate. But this regulated. As the sun's radiation increased, the object responded, not by breaking down, but by compensating, cooling, stabilizing, heating, again and again, like it was maintaining a range, like it knew what temperatures it preferred. That thought hit harder than the pulses ever did, because light patterns can deceive. Motion can mislead. But heat is honest. Thermal data doesn't care about imagination. It tells you how energy moves, where it goes, how it's handled. And this energy wasn't behaving naturally. Across multiple instruments, the same behavior appeared. The same rise, the same fall, the same controlled plateau. The object wasn't just surviving the sun, it was managing it. That word, managing, changed everything, because management implies boundaries, limits, design. In closed meetings, scientists stopped comparing 3I/Atlas to comets. Those models failed completely. They stopped comparing it to asteroids too. Instead, they compared it to systems, insulated structures, layered materials, thermal shields, things humans build, things that need to protect something inside. But no one said that part out loud. They just stared at the charts. The sun poured energy into the object at a rate that should have overwhelmed it. Any normal surface would have heated unevenly. Hot spots, cold shadows, chaos. This surface stayed calm, balanced, almost indifferent. The temperature didn't follow distance alone. It followed response. When radiation increased, cooling followed. When cooling overshot, heating resumed. A feedback loop. A controlled loop. As if the object wasn't just enduring space, but operating within it. One researcher wrote a note in the margin of a graph, active thermal behavior. They stared at the words for a long time before saving the file. Active, not passive. That distinction mattered. Because passive objects suffer heat. Active systems handle it. The closer 3I/Atlas moved toward perihelion, the more obvious it became. The sun wasn't stripping it apart, it was testing it. And the object was passing. No visible erosion, no expanding debris, no wild temperature spikes, just control. Cold, then warm, then stable. Like breathing under pressure. The idea that this could be accidental became harder to defend with every new dataset. This wasn't survival by chance. It was survival by design. And design leads to uncomfortable questions. What was being protected? What required this level of thermal precision? And why send it through the most dangerous part of the solar system, unless it was meant to? There's a moment in every investigation when curiosity turns into caution. This was it. Because if the object could regulate its temperature near the sun, then heat wasn't a threat. And if heat wasn't a threat, then what was? The silence around the data grew thicker. Reports became shorter. Language became softer. Instead of anomaly, some began using behavior. Instead of unexpected, they wrote consistent. The object wasn't misbehaving. It was performing. As perihelion approached, something else became clear. The thermal regulation tightened. Less fluctuation. Faster response. Like a system locking in, preparing. The sun was no longer just a heat source. It was a trigger. And triggers imply sequence. Sequence implies intention. This wasn't an object being cooked. This was an object reacting, which raised a question no one wanted to face yet. Why would a drifting interstellar object need to manage its own temperature unless temperature mattered to what it carried, or what it was? The universe is full of cold, dead things. They don't care if they freeze or burn. They simply exist until they don't. But systems care. Machines care. Not emotionally. Functionally. Because failure has consequences. And as 3I/Atlas slipped deeper into the sun's influence, it didn't look like something close to failing. It looked like something doing exactly what it was built to do. The data didn't scream. It whispered. Over and over. This object is not reacting like matter, it is responding like a process. And once that realization took hold, there was no going back. Because now the question wasn't whether 3I/Atlas was unusual. The question was whether it had ever been natural at all. As the sun blazed ahead and perihelion drew closer, everyone watching understood one thing. If this thing could control heat, then the most dangerous part of the journey wasn't behind it. It was ahead. Because the true test wouldn't be temperature alone. It would be precision. And precision has a way of revealing whether survival is accidental or intentional. Perihelion is where objects confess. It's the point of no excuses, the place where predictions become truth. As 3I/Atlas closed in on the sun, every model on every screen said the same thing. It shouldn't make it through intact. This was the danger zone. Radiation climbing fast, gravity pulling hard, heat pressing in from every side. This is where comets break open, where asteroids fracture, where ancient travelers finally show their age. So scientists prepared for the moment of chaos. They expected flares, cracks, sudden brightness spikes as material tore free. They expected noise. What they got was control. As the object reached its closest point to the sun, something strange happened. The thermal data didn't spike. It narrowed. Instead of wild swings, the temperature curve tightened into a clean band. No sharp rises, no sudden drops, just balance. Like a system locking itself into place. The closer it got, the calmer it became. That was the first sign something was deeply wrong with the assumptions, because perihelion doesn't reward calm. It punishes weakness. Yet 3I/Atlas didn't weaken. It stabilized. Heat poured in at levels that should have overwhelmed any exposed surface. But the object didn't flash brighter. It didn't vent. It didn't shed mass. It adjusted. Faster now, more precisely. Cooling kicked in exactly when needed. Heating followed only when required. The response time shortened, like a system refining itself in real time. Not struggling, optimizing. That word sat uncomfortably in the background. Optimizing. Nature doesn't optimize under stress. It breaks, or it survives by luck. This wasn't luck. This was behavior. Across simulations, researchers watched the predicted chaos fail to appear. The models fell apart instead. Every assumption, built on natural physics, collapsed under the weight of observation. The object didn't tumble. It didn't wobble. It didn't lose orientation. It held its posture, like it was braced, like it knew exactly how much punishment was coming, and had planned for it long before entering the inner solar system. Perihelion came and went without spectacle. No dramatic tale, no explosive release, no final scream of ancient ice, just a quiet passage. That silence was louder than any flare could have been, because it meant the sun had tried and failed to disrupt it. In monitoring rooms, eyes stayed locked on screens long after the moment passed. People waited for the delayed collapse, the aftershock, the failure that sometimes comes late. Nothing happened. The object didn't relax either. It didn't drift into randomness. It maintained control, as if perihelion wasn't an ordeal, but a checkpoint, something it had crossed before. The thermal pattern after closest approach was even cleaner than before. Less variation, tighter margins. as if the system had learned. That's when a dangerous thought surfaced. What if the sun wasn't just something to endure? What if it was part of the process? Perihelion isn't just heat, it's energy. Massive amounts of it. The kind that powers reactions. The kind that activates things. The idea wasn't spoken loudly, but it spread quietly. This object didn't just survive the sun. It used it. And that changes everything. Because survival is passive. Design is intentional. In nature, precision degrades with stress. Here, precision increased. That's not erosion. That's refinement. Somewhere between the data and the silence, a line was crossed. Up until now, 3I/Atlas could still be defended as strange but natural. Rare, yes. Unlikely, maybe. But still within the long tail of cosmic weirdness. Perihelion ended that defense. Because no natural object tightens its behavior under extreme stress. No natural traveler arrives ancient, intact, precise, and leaves even more controlled than before. The sun is supposed to be the great equalizer. Instead, it became a test, and 3I/Atlas passed. As the object moved away from the sun, something unsettling became clear. It wasn't damaged. It wasn't depleted. If anything, it looked ready. Ready for what? No one knew. The pulses continued. The light curve remained stepped. The thermal system stayed active. Nothing shut down. Nothing relaxed. Machines don't relax. They complete phases. And phases imply sequence. Sequence implies purpose. At this point, the question could no longer be avoided. Is this survival or design? Because survival explains endurance. Design explains preparation. And preparation implies foresight. Something had crossed interstellar space, entered our system, endured the sun, and emerged unchanged. Not by chance, by control. That realization didn't cause panic. It caused something colder. Restraint. Because once you accept design, you must accept an origin. And origins lead to intent. Was this object built to last or built to observe? Was perihelion a risk or a requirement? The data didn't answer those questions, but it removed excuses. As 3I/Atlas drifted away from the sun, the sense of anticipation didn't fade. It grew because now everyone understood one thing. If this was a machine, then perihelion wasn't the climax. It was the calibration. And whatever came next was not about survival anymore. It was about purpose. And purpose, once revealed, has consequences far beyond the sky. The word didn't appear all at once. It slipped in quietly. At first, it showed up between sentences, in the space where certainty used to live. No one typed it in bold. No one said it in meetings meant to be recorded. But it was there, artificial. A word heavy enough to change the air in a room. Up until now, everything could still hide behind probability, rare physics, unknown materials, extreme coincidence. But perihelion took those shields away. And once the data stopped breaking and started behaving, the language had to change. Internal reports shifted tone, not dramatically, subtly. Unusual became consistent. Unexpected became repeatable. Anomaly became behavior. These weren't emotional changes. They were defensive ones. Because once you consider artificiality, you can't unthink it. You start asking different questions. Not what is it made of, but what is it doing? Not how did this happen, but why was it built this way? And most dangerous of all, why now? Access to certain datasets quietly narrowed. Not locked, not erased, just controlled. Some files required approval. Some graphs stopped circulating. Some meetings stopped inviting everyone they used to. No official explanation was given. There didn't need to be. Everyone understood the instinct. If this was just another object, openness was safe. But if it wasn't, then words mattered. Because words shape reactions. And reactions spread faster than facts. The idea that this could be a machine wasn't exciting. It was destabilizing. Machines imply makers. Makers imply intent. And intent implies choice. That's the part humanity struggles with the most. Because a natural disaster doesn't judge you. A rock doesn't care who you are. But something built had a reason. And reasons create unease. The analysts who first leaned toward artificiality didn't do it lightly. These were cautious people, trained to doubt their own instincts. But the patterns were stacking. Controlled light, regulated heat, stability under stress, consistency across systems. Individually, each could be argued away. Together, they formed a shape. Not a physical one, a conceptual one, a system. And systems are not accidents. One internal note asked a simple question. If this is a probe, what phase are we observing? That line was deleted before the document was finalized. But it lingered. Because probes don't announce themselves. They observe, they pass through. They collect. And then they leave. Which raised a chilling possibility. What if 3i/Atlas wasn't arriving? What if it was checking in? That idea stayed buried beneath layers of professionalism, but it influenced decisions. Why rush public disclosure? Why invite speculation before understanding the risks? Because once the word artificial escapes into the world, you can't contain it. The story stops belonging to science. It becomes cultural, philosophical, existential. So the silence continued. Not because of conspiracy, because of caution. The universe had just whispered something unsettling, and humanity wasn't ready to speak back. If this object was built, it was built long ago, long before Earth had technology, long before humans looked up and wondered if they were alone, which meant its creators were either gone or unimaginably patient. Neither option was comforting, and then came the most troubling realization of all. If this was artificial, it wasn't new. It wasn't reacting with curiosity. It wasn't adjusting with confusion. It moved like something experienced, like something that had done this before, passed through star systems, skirted suns, survived radiation. That implies scale. A civilization capable of building something that lasts millions of years, that crosses interstellar space intact, that functions without maintenance. That civilization doesn't think like we do. They don't rush. They don't panic. They don't need to arrive loudly, which begs the question no one wanted to ask directly. Why send it here at all? Earth is not special in size. The sun is not rare in brightness. But something about this system mattered enough to pass through. Not stop, not land, just pass. Observe, record, and move on. That possibility unsettled people more than invasion ever could. Because invasion implies urgency. This felt indifferent, like a scientist flipping through slides, like a surveyor checking a box. The object didn't slow down to greet us. It didn't change course to avoid us. It didn't care, which suggests we were not the target. We were the environment, and that realization reframed everything. Maybe the machine wasn't here for Earth. Maybe it was here for the sun, or the gravitational layout, or something we haven't noticed yet. Because the most advanced tools don't study what's obvious. They study what's subtle. Internal discussions became quieter, more abstract. Philosophers were consulted quietly, systems engineers, not to speculate wildly, but to understand behavior. How would you design something to last this long? How would you send it without knowing who would find it? How would you ensure it doesn't interfere unless necessary? These weren't questions for headlines. They were questions for survival. Because if this was artificial, then this wasn't a random event in cosmic history. It was part of a process, and processes have steps. Steps implies sequence. Sequence implies we are not at the end. Maybe not even the middle. Maybe just a moment that happened to be noticed. As 3I/Atlas continued its journey away from the sun, nothing dramatic occurred. No final message, no sudden change, just the same controlled behavior, like a machine that had completed a task and moved on to the next. And that's when the most unsettling thought took hold. What if the reason it didn't announce itself was because it didn't consider us relevant enough to announce itself too? If this was a machine, it wasn't asking for attention. It wasn't asking for permission. It wasn't asking anything at all. It simply passed through our sky, unchanged, uninterested, complete. And that leaves us with a question that doesn't fade with distance. If something artificial crossed our solar system, noticed us, and chose silence, who built it? And what did it learn while it was here? It didn't begin with an announcement. It never does. It began with fragments, a screenshot shared too late at night, a clipped sentence from a leaked email, a chart posted without context, then quietly deleted. At first, no one noticed, but the internet has a way of sensing tension before facts appear. People felt it. Something was different. A rare object passes through the solar system, and there's no celebration, no big explanations, no confident answers. Silence invites imagination, and imagination fills gaps fast. Forums lit up. Comment sections grew longer. Amateur analysts slowed down footage, traced graphs, overlaid public data. They weren't experts, but they were curious, and curiosity spreads faster than authority. Words began circulating. Carefully at first. Strange. Too precise. Doesn't look natural. Then the bolder ones appeared. Artificial. Probe. Watcher. At first, scientists dismissed it as noise. Online speculation always blooms around the unknown. This wasn't new. What was new was how hard it was to push back, because the official explanations felt thin. Careful, incomplete. They didn't lie. But they didn't reassure either. And when certainty hesitates, people notice. The idea that intelligence might have crossed our system without stopping, without speaking, hit something deep. Not fear, displacement. For centuries, humans have looked at the sky as observers, students, explorers, dreamers. The universe was the stage. We were the audience. But now, that frame felt unstable. Because what if the roles had briefly reversed? What if, for a short moment, something passed through, and we were the data? That thought spread quietly, like a shadow moving across a room. People started looking up more often, not with wonder, with suspicion. The stars didn't change, but the meaning did. Late-night conversations shifted. Astronomy channels gained viewers. Philosophical questions slipped into everyday talk. What if we missed something? What if it wasn't meant for us? What if it already left? Knowing more than we do, none of these questions had answers. And that was the problem. Humans don't struggle with bad news. They struggle with uncertainty, especially the kind that suggests we are not central. Public trust in clean explanations began to erode. Not collapse, just crack. Small fractures, because the story no longer felt complete. The object had come and gone. The data was strange. The silence was louder than the facts. And silence invites interpretation. Some people reacted with humor, jokes, memes, casual dismissal. Others felt something heavier, a quiet humility. The idea that intelligence might exist and move through our neighborhood without noticing us. Rearranged perspective. It wasn't an invasion story. It wasn't contact. It was worse and calmer. Indifference. Being ignored is harder than being threatened, because threat implies relevance. Indifference implies scale. People started asking different questions. Not, are we alone? But, have we ever mattered? That sounds dramatic, but perspective shifts often do. The sky, once a symbol of hope or mystery, began to feel occupied, not crowded, just not empty. And emptiness was our comfort. Teachers noticed students asking deeper questions, not about aliens, but about meaning. What does progress mean if others are already beyond it? What does discovery mean if someone else discovered us first? What does observation mean if it goes both ways? The idea that we might not be the first to notice, but the last, unsettled something old and fragile. Human certainty. Because certainty is not built on facts alone. It's built on stories. And the story we've told ourselves for a long time is simple. We are explorers. We are early. We are becoming. 3I/Atlas didn't disprove that, but it complicated it because it suggested something else had already been, already crossed distances we still dream about, already mastered conditions that still scare us. And it did so quietly. No warning. No announcement. No care. Some people felt smaller under the stars. Others felt sharper, more awake. Because there's something powerful about realizing you're not the center. It forces honesty. The sky wasn't hostile. It wasn't welcoming either. It just existed. And maybe that was the truth. All along, as weeks passed, the rumors didn't fade. They matured. Less wild speculation, more thoughtful unease. The question stopped being, is this real? It became, what does this change? Because even if every theory turned out wrong, even if 3I/Atlas was someday explained away as rare physics, something irreversible had already happened. Perception had shifted. The idea that intelligence could pass through unnoticed and choose silence had entered the human story. And stories don't leave easily. We still track satellites, still launch probes, still scan the sky. But now when we look up, there's an added layer. A quiet awareness. What if we are not just watching? What if observation goes both ways? What if the universe has already noticed us and simply moved on? That thought doesn't scream. It lingers. It changes how you feel standing under the night sky. You don't feel threatened. You feel measured. And maybe that's the deepest shift of all. Because once you realize you might be part of someone else's dataset, you stop asking only what's out there. You start asking, what are we becoming? Are we observers anymore? Or subjects who didn't know the experiment had already begun? Everyone expected a message. That's the story we've trained ourselves to believe. If intelligence ever reaches out, it will speak. In radio waves, in math, in something we can decode. So scientists listened. They pointed antennas toward the path 3I/Atlas had taken. They scanned old recordings. They searched for spikes, bursts, anything that looked like a transmission. There was nothing. No radio signal, no repeating frequency, no hidden message buried in noise. Silence. At first, that silence felt reassuring, because without a message, there was nothing to panic about. No greeting, no warning, no demand. Just a strange object, behaving strangely and moving on. But then the silence started to feel wrong. Because if this was artificial, if this was built, why stay quiet? The question hung in the air longer than any signal ever could. Maybe the assumption itself was broken. Maybe we were listening for the wrong thing. Because not all signals are meant to be heard. Some are meant to be seen. When researchers stopped searching for sound and started re-examining behavior, something clicked. The pulses in brightness, the stepped light curve, the precise motion, the thermal control. None of these were random, and none of them carried information in the way humans expect. There were no numbers to decode, no prime sequences, no universal constants spelled out, just patterns, consistent, repeatable, observable. Patterns don't shout, they reveal. The object never tried to talk. It never needed to. Because language assumes misunderstanding. Patterns assume intelligence on both sides. You don't send a radio message unless you want to be answered, but you show behavior when being noticed is enough. That realization shifted everything. What if the signal wasn't communication? What if it was confirmation, a way of saying, I am not random. I am not natural. I am here, and nothing more. The pulses weren't trying to convey meaning. They were demonstrating control. The thermal behavior wasn't signaling distress. It was proving capability. The motion wasn't waving hello. It was showing precision. Every anomaly was visible, measurable, undeniable. Anyone watching closely enough would see it. Anyone capable of observation would notice. That reframed the silence in a disturbing way. Maybe the object didn't stay quiet because it had nothing to say. Maybe it stayed quiet because it didn't care who noticed. Just that someone could. Think about it. If you were sending something across the galaxy, something meant to last millions of years, you wouldn't rely on fragile language. Languages die. Symbols fade. Radio waves scatter. But physics? Physics is shared. Light, heat, motion. Those are universal. Anyone advanced enough to watch the sky understands them. So instead of speaking, the object behaved. It acted in ways that could not be explained by chance. It crossed thresholds. It responded to stress. It demonstrated agency without ever saying a word. That's not a message. That's a test. not of our technology, but of our perception. Could we tell the difference between noise and intention? Could we recognize design without being told? Could we see a signal that didn't announce itself? Because if intelligence is ancient enough, it doesn't need to introduce itself. It simply passes through and waits to see who notices. The idea was unsettling, because it meant the absence of a message wasn't a failure. It was the point. Those who expected a voice heard nothing. Those who watched behavior saw everything. And that raises an uncomfortable question. If this was a signal meant to be noticed, who was it meant for? Humanity, or any intelligence capable of detecting it? Maybe Earth wasn't special. Maybe the solar system was just another waypoint, another place where eyes might exist. If something passed through thousands of systems like ours, most would never know. No telescopes, no instruments, no observers, just stars burning quietly. But if a system did notice, if someone did see the pattern, then that system had crossed a line. It had become aware. Not contacted, not chosen, just aware. The object didn't stop to explain. It didn't slow down to wait for applause. It didn't repeat itself louder when no one responded. It moved on, as if the act of being seen was enough. That's what made the silence heavy, because silence in this context wasn't absence. It was restraint, a decision, and decisions imply judgment. Maybe the signal wasn't asking, "Are you there?" Maybe it was asking something far colder. Can you tell the difference? Can you tell when something is built and when it is born? Can you recognize intention without being guided? Because that ability says more about a civilization than any radio reply ever could. If this interpretation was right, then humanity didn't miss the signal. We are the response, our reaction, our confusion, our debates, our shift in perception. All of it is data. And that's when the thought became impossible to ignore. What if 3I/Atlas wasn't reaching out? What if it was checking in, not to speak, but to see who was ready to notice? And if that's true, then the most important part wasn't the object itself. It was what happened after, the way scientists hesitated, the way language changed, because the real signal may not have been light or heat or motion. It may have been psychological, a nudge, a disturbance, a reminder that intelligence does not have to announce itself to exist. And if that's the case, then silence isn't empty, it's deliberate. The object left no message because it didn't need to. It left something far more permanent: doubt, humility, awareness. And once those take hold, they don't fade when the object disappears. As 3I/Atlas moved farther away, the pulses weakened. The patterns softened. The anomalies slowly slipped back into background noise. But the question remained. If the signal was never meant to be heard, if it was meant to be noticed, then what happens when the next one comes? Will we see it sooner? Will we understand it faster? Or will we realize, too late, that the universe has been signaling us all along, not with words, but with patterns we're only just learning how to see? The silence didn't come all at once. It arrived slowly, like a sound fading as something moves farther away. As 3I/Atlas began its journey out of the inner solar system, the pulses weakened. Not abruptly, not dramatically. They softened. The sharp steps in brightness smoothed just enough to feel distant. The thermal responses became harder to separate from background noise. The patterns didn't stop. They simply became harder to see, like a signal moving out of range. This was the part everyone expected to feel relief. The danger had passed. The mystery was leaving. Normalcy could return. But relief never came. Because nothing about this ending felt finished. The object didn't slow down. It didn't linger. It didn't adjust course as if reconsidering. It left the same way it arrived. Quiet. Controlled. Uninterested. As if the most important part of its journey had already happened. And now it was done. The last clean datasets were archived carefully. Time-stamped, indexed, stored. No conclusions attached, just observations. Light curves frozen in place, thermal graphs locked in folders, motion paths plotted and saved, evidence without interpretation, because interpretation was where things got dangerous. The official language returned to safety. Object exiting observation range. Further study unlikely. No anomalous emissions detected. True statements, but incomplete, because what lingered wasn't in the data. It was in the questions no one could answer. If this was a machine, it never slowed down to see if we noticed. If this was artificial, it didn't wait for reaction. If this was a probe, it behaved like one that already knew the outcome. That detail bothered people more than anything else. There was no curiosity coming from it, no adjustment after detection, no change once it was clearly being observed. It didn't care that we were watching. Which suggests one of two things. Either it never noticed us, or noticing us was irrelevant. Both possibilities were unsettling, because relevance matters, and whatever built this object didn't need ours. As weeks passed, attention drifted. New headlines arrived. New crises took center stage. But among those who watched the data closely, nothing felt resolved. Because you don't just forget something like this. You don't unknow a pattern once you've seen it. The object was gone, but the shift remained. Astronomy didn't feel the same anymore. Before, anomalies were puzzles to solve. Now, they felt like behaviors to interpret. Before, silence meant absence. Now, silence felt intentional. The sky returned to its usual calm. Stars burned quietly. Planets followed their paths. But the idea of emptiness had changed. Because something had passed through and left without explanation. People asked the obvious question, did it find what it was looking for? No sensors suggested it slowed to observe Earth specifically. No instruments detected scans aimed at us. No signals pointed toward life or civilization, which made the question heavier. Maybe we weren't the target. Maybe the sun was. Or the gravitational structure, or something subtle we don't yet understand. Something embedded in physics itself. If this was a machine, it may not have been searching for intelligence. It may have been measuring conditions, energy flows, stellar output, system stability, things that matter to long-term planners, things that matter to builders, and that implies scale beyond imagination. A civilization that sends machines like this doesn't rush. It doesn't check in every few years. It works on timelines, longer than species, which means this may not have been the first, and it almost certainly won't be the last. That realization sat quietly in the background. No panic, just awareness, because the object didn't leave behind proof of danger. It left behind proof of possibility. The possibility that we are not alone in being curious about the universe. And the possibility that curiosity doesn't always look like us. As the pulses faded into noise, One final detail stood out. There was no shutdown, no sign of exhaustion, no decay. The systems, whatever they were, didn't fail. They simply became harder to detect, which suggests continuity. The object didn't end, it continued. Somewhere beyond our instruments, beyond our range, beyond our certainty. Still moving, still operating, still silent, and silence, once again, felt deliberate. If it was a machine, it behaved exactly like one designed not to interfere, not to announce, not to disrupt, just to pass through, observe, and move on. That's not how invaders behave. That's how surveyors behave. That's how archivists behave. That's how something acts when it doesn't need to rush, because time is abundant. As months passed, the world moved forward. But for those who followed 3I/Atlas from discovery to departure, something fundamental had changed. The universe no longer felt passive. It felt inhabited by processes, by systems older than us, by intelligence that doesn't need permission. The object never slowed down. That detail matters, because slowing down would suggest curiosity. It would suggest interest. It would suggest uncertainty. This showed none of those, which leads to the most uncomfortable question of all. If it didn't slow down, then maybe it already knew the answer. Maybe the data it needed wasn't collected here. Maybe this system had already been catalogued, measured, filed away, long before humans ever looked up. And if that's true, then what we witnessed wasn't first contact. It was a routine pass, a quiet moment in a process far larger than us. The silence after observation wasn't emptiness. It was closure, not for us, but for whatever sent it. And that realization leaves a lingering chill. Because if something crossed our system, gathered what it needed, and left without slowing, then the most important question isn't what it was. It's what it learned, and whether, from its perspective, we mattered at all. As the sky returned to stillness, one truth remained. The object is gone. The data is archived, but the feeling hasn't faded, because once you realize the universe might be watching, silence stops being comforting. It becomes a pause, and pauses suggest something may come next. Not soon, not loudly, but eventually. And when it does, the question won't be whether we notice it. The question will be, what will it notice about us? At some point, the numbers stopped updating. The last observation window closed. The final tracking arc faded beyond precision. 3I/Atlas slipped past the edge of what our instruments could follow, not with drama, not with resistance. It simply became another faint point, then nothing at all. Gone into deep space, back into the dark between stars. And that should have been the end. That's how these stories usually finish. An object comes, an object leaves, life goes on. But this one didn't end that way, because even after the sky returned to normal, human perception didn't. Something subtle had shifted, not in the universe, in us. The charts were archived, the debates slowed, the headlines moved on. But the questions didn't fade. They just went quiet, like thoughts you don't say out loud anymore, because you don't know how to answer them. If this was natural, it was unlike anything we've ever seen. If it was artificial, it was unlike anything we imagined. Either way, it didn't fit the stories we were comfortable telling. And comfort matters. For a long time, humanity has lived inside a simple frame. We explore, we discover, we expand outward. The universe waits to be understood. 3I/Atlas cracked that frame because it suggested something else. That exploration might not be one-directional. That discovery might already have happened from the other side. If this was a test, we never knew the rules. There was no instruction manual, no clear objective, no moment where someone said, "This is what's being measured." Just behavior, patterns, silence. Which raises an unsettling possibility. What if the test wasn't technological? What if it wasn't about radio signals or spacecraft or math? What if it was perceptual, a test of awareness, of humility, of whether we could recognize intention without being told? Because that kind of test doesn't come with answers. It comes with consequences. And those consequences aren't immediate. They unfold slowly inside culture, inside science, inside the way people think when they look up at the night sky. After 3I/Atlas, the sky didn't feel empty anymore. Not crowded, just inhabited by possibility, by the idea that intelligence doesn't have to announce itself, that it doesn't need contact to have impact, that it can pass through, change how you think, and leave without explanation. That idea doesn't cause panic. It causes restraint, a quiet recalibration. People became more careful with certainty, more cautious with claims like "we know and we understand," because something had just reminded us. Understanding is provisional, temporary, conditional. The universe didn't answer us, but it asked something of us, and we're still not sure what. If this was a warning, it wasn't a loud one. There were no threats, no countdowns, no signs of danger, just a demonstration of precision, of endurance, of capability. Warnings don't always say stop. Sometimes they say notice. And that might be the hardest kind to hear, because if we missed it, we wouldn't even know what we missed. There's a certain kind of fear that comes from loud possibilities. Asteroids, explosions, invasions. This wasn't that. This was quiet. And quiet things tend to stay with you longer. Because they don't force reaction, they force reflection. The object had an origin, but we never found it. No star system clearly pointed back to it. No cosmic fingerprint gave it away. Its past remained as dark as the space it vanished into. And maybe that was intentional. Origins matter less than behavior. Creators matter less than outcomes. If something crossed the galaxy and reached us, the important question may not be where did it come from. It may be, what does its existence imply? It implies patience beyond generations, engineering beyond decay, planning beyond urgency. It implies intelligence that doesn't need recognition. And that idea doesn't threaten humanity, but it does humble us, because humility is what comes after certainty breaks. The object is gone, but the frame through which we see the universe has shifted. Before, the unknown felt like something waiting for us. Now, it feels like something that may already know us. That doesn't mean we're doomed. It doesn't mean we're chosen. It means we're not alone in curiosity. And we may not be the first to arrive. If this was a test, we don't know if we passed or failed. If it was a warning, we don't know what it warned us about. And maybe that's the point. Tests that explain themselves aren't tests. Warnings that announce themselves are easy to ignore. The most powerful ones change how you think without telling you why. 3I/Atlas didn't bring answers. It brought a shift, a quiet awakening, a fracture in certainty. And fractures are where light enters. The universe didn't reveal its secrets, but it revealed something about us, that we listen for voices, but overlook patterns, that we expect messages, but miss demonstrations, that we assume importance, without questioning perspective. The object disappeared into deep space, but something stayed behind. A question that doesn't fade with distance. If intelligence can pass through our system, observe us, and leave without slowing, then the universe is not waiting. It's already moving, already measuring, already unfolding on timescales we barely touch. And whether that's comforting or unsettling depends on how ready we are to let go of being the center. The sky is quiet again. Stars burn, planets turn. Life continues. But now, when we look up, there's a pause, a hesitation, a thought we didn't have before. What if the truth wasn't hidden from us? What if it passed right through our hands and we didn't know what to do with it? If this was a warning, did we just miss it? And if it was a test? The most unsettling possibility of all is this: the test may not be over. We may just be waiting for the next time the universe decides to see if we notice.